simulation, right? Here's where I get all my simulations from, right? Share you, let me know if it's working, right? I'll tell you when I'm sharing. Right, there's normally one PHP and physics class, right? That's normally use these two, PHET or physics class. Right. All right. There's not anyone else. Share, you seen a little simulation there?
Yes.
Okay, nice. All right, now this one, pull up. There's not a simulation. So we're gonna take a look at pressure, right? So we're gonna talk about pressure, and I'm gonna give you some of the definitions just now, right? But let's see what occurred here. Right? Let me just pull this thing right. Right. So what you will notice is that each of the bottles have a hole. The little black spot there is a hole. You see that? And I'm going to I don't figure out how to pour the water in. But we're going to observe what is happening to the water as it comes up, right? I move the water now. I take the first. Oh, I have double click. Right. So I just take the hole, right? Nice. Now I can pour the water. Pour some water in there and we're going to see what will happen. Come back again, come back again. Right. More. Right. Next one was right. So you pour in water in there. And then we're going to remove the tape and we're going to observe what is happening to the water as it comes out the hole. And what it's going to teach us, it's going to teach us about pressure. Right? So watch this here. You see the let me take off the tape now. There you partner. So you make it put the water there for I don't know the simulation, so that. Hold on then. Oh, remove cell tape. Right. Watch it there. See the water? Look at the one with the hole is much higher. Is it going far away from the desk? No. But As I put the hole lower, you recognize that the water going out much further. What does that say about pressure? It increases with depth, everything. Like that's the exact way I was going to say, right? As you go lower, as the depth increases, pressure increases. That's the reason why the water's putting out, right? You'll ever like jump in a pool or in the ocean, and you know where your head is it, right? Or you know this where your head is it. So the reason for that is that pressure. The reason for that is that the pressure gets larger as you move down. Okay, so we need to learn. Okay, what is causing that pressure? What do you think is causing that pressure? Why it is the lower you're going, more is hurt, or the water squirting out more? Yeah. You weight of the water on top of you, right? Okay, I'll take that. I will take that. So first thing he said is that the weight of the water, right? Weight. I didn't write it over there, but that's weight, right? You may or may not know that weight in physics is the mass by gravity. Okay? So because you have more water on top of you, is the reason why the pressure is larger. That's okay? Shia, you okay with that?
Yes.
Right? So what you say? There's one more formula that you all will learn. You all learn this in Form 1, density. We're talking about, you must have learned it in Form 1 and Form 2. We're talking about density. Density is what? Shreya, you ever heard about something called density? Right?
Yes.
I think so. So the density is the mass of the substance over its volume. The mass of the substance over its volume. Alright? And if you do a little bit of maths, you're going to end up with the mass of the substance being density by volume. Okay? Either way, I'll give you a small note test one. Right? So in short, what I'm trying to show you here is that pressure is dependent on weight, which is mass by gravity, or density by volume by gravity. Right? And one more thing is dependent on, but you're not gonna see it here. Right? But you're okay with the question like with it, right? And then one more thing I want to see that affects pressure. One more thing I want to speak about what I'm saying was pressure, right? So we said the weight affecting it, right? Something else affecting it, but you wouldn't see it there. What's this simulation here? Right, what you see. So if you look closely there, right? Which one exerting the greater pressure, the red or the blue? The blue, right? Because the blue is what? Blue is what? Blue looks larger. So the blue have a greater weight, just like the example of we just learned about. You okay with that? But what you're saying? You recognize something? You recognize that the red exerting a greater pressure there? When I turn it, or turn it back. See, less pressure. When I turn it, bigger pressure. What is changing there? Right? Usually like word there. The word there, Shreya, is area. So you would recognize that the area here is smaller. So and that would is area, right? So two things affect pressure. Pressure is affected by the force or the weight and the area. So we end up with this nice relationship of pressure, force divided by area. Okay? So the smaller the area, watch it here. Look at the small area here compared to when I turn it around. Exerting as bigger pressure. So the bigger the area, smaller the pressure. Smaller the area, bigger. Right? I just increase the force there. See pressure increasing. Turn it up, turn it. And I'm going to increase the force. And you will see the pressure is much larger. Okay? So pressure is dependent on force and the dependent on area. Okay? So we see pressure in action here. Pressure in a solid here, and I showed you pressure in a liquid a while ago. And I want to show you one more here. Show you another one, right? Let's just go back to the whiteboard. All right. So hydrostatics is about pressure. Right? So if I ask about pressure, pressure is the force acting per unit area. So we would see that pressure is equal to force over area. Right? If you remember from last day, I told you that the SI unit for force was Newton. You might know that the SI unit for area is meter squared. So the SI unit for pressure is Newton meter minus 2. Right? Or the one that we'll use a lot as well is something called pascals. PA. Pascals. Okay? So this shows us that pressure is dependent on force and area. Make a little note, write down the SI unit. Right? So let's look at some practical examples and why, right? Double cutlass here. Right? My question to you, right? This is a knife, right? Let's say it's a knife. On this knife, which side of the knife is sharp? Underneath here, most likely, right? This side is the sharper side. And this side, dull side. Based on what you just learned about pressure, see if we can explain why. Think about the knife. Yeah, here. Right. So when it's sharpen the knife, here's be a smaller area, right? And here's be a little bit thicker, right? And we just learned that the smaller the area, the bigger the pressure. Okay? So the knife here is sharper because it has a smaller surface area. Right? And of course, here's dull because it has a larger surface area. And I'm sure you can think of many other examples where you see this. think about it. See, anybody give me an example? So you can give me an example of where you see the difference in pressure popping up. Right? So we can think of an example. Anybody? An example where you see the difference in area affect pressure. Shreya, any examples that you can think about? Ashish, any example you can think about? Think of a nail. Think of a nail. Right? For a nail to enter into like wood, for example, what must happen? The point of the nail must have a small surface area, right? But if the nail doesn't have a small surface area, what will happen? It will be harder to penetrate, right? Anything else? Have plenty of examples. But when you go home, you might see. Right? But have plenty of examples where you will see that smaller surface area will give you a sharper pressure. Take a pencil, for example. If you apply a force, right? If you apply a force on the pointy side, attach to your finger and you apply a force, you'll recognize that it will hurt a lot more than turning it around and applying the same force. Right? So the pointier side applying a bigger force. So you have bigger pressure. Okay? So as we see that pressure is dependent on force and area. And then we learned a little while ago in a liquid, right? We learned that in a liquid, if I give you a container, let's say the container is filled with water, and I make 1, 2, 3 holes, we will see that the water will come out here, a little bit further here, and the furthest on the next one. Right? What that means in a liquid, pressure is dependent on depth. So the formula should give you that, right? So pressure in a liquid is a solid, right? This one is solid, pressure on a solid. Pressure on a liquid is density by gravity by height. Right? This symbol is density. This symbol here is gravity. And the last is depth. Share you see the marker?
Yes.
Okay. Well, let's cheat. Right? I'm giving you the SI units here one time, right? kgms kilograms per volume. Right? These little things on the end is called the SI unit. Right? But when you finish, here's what you think about. I taken a container full with water and I put in 3 holes at the same level. 3 holes at the same level. I want you to try to show me what will happen to the water coming out. So I put in 3 holes at the same level. See if you can figure out what will happen to the water. Right? What will happen to the water as it comes up. Right. Everybody got a little chance. Michael. Guidance. Right. What do you think? Shreya. Shreya, tell me what you think now. If you put the holes at the same level, what do you think will happen?
All the water will flow out at the same level.
Right. So the water was pulled out at the same distance. What does that say? Pressure at the same depth is the same, right? So what you will observe here, is that the pressure positive to come out the same distance. Right? So you're writing pressure is the same. Pressure is the same at the same horizontal depth. All right. Now we can go on to the application here. Right, so we learned about pressure in a solid dependence on force area. Pressure in a liquid is dependent on depth, right? At the same horizontal level, the pressure is the same. Now, get to see our application of this for the hydraulic lift. Right? Do you think that's possible? A little skinny guy there being able to lift up a car? Yeah, but it should be possible. I don't even maybe sign up it. Right? It should be possible. What do you think? Possible? Yeah, should be, right? So this skinny guy here, supposed to be able to lift something, as they say, 20 times heavier, right? We see and give us no values in this one. Right. So what it's showing you here is that if I make the area here bigger and the area on the left side smaller, see what happened? Can't move in the skinny guy. Right? But if I make the area to the left much smaller, skinny guy. Right, gives us mass. You'll be able to lift the car, right? That's just like it's not reading thing. That's the skinny guy one. I think I'm going back down. Right. So what's skinny guy here? Keep adding skinny guy. We have about 4 so much skinny guy. Right. We allow skinny guy now to raise this. Right? But I'm going to give you some actual values, right? Hold on. Let's check see the next simulation allows us. There's one that has values. Physics lens. Alright, it's not bad. So what it's showing you here is there's a force of 3 newtons, giving you a force of 6 newtons here. The area that's here. Here is area 1. And here is area 2. Area 1 is about 2 units. Area 4 is 4 units. And a 3 Newton force can lift a 6 Newton force. What we have to be able to do is calculate why. Why that happening? Right? So I'm going to use these same numbers here and show it. Right? So here's 3 newtons. Right? What's the pressure exerted here? We know that pressure is equal to force over area. Did I give it up? The force is 3 newtons and the area is 2 units, right? So you put in 3 over 2. Right? So the pressure exerted is 3 over 2. Right. Here's what's really cool about this liquid. This liquid cannot be compressed. So no matter how much you squeeze it, it's going to have the same volume contact. Right? So because of that, it's going to carry the pressure from the small piston to the big piston. So the pressure here is the same thing, which is 3 and 2. All right, man? 3 up. You okay so far?
Yes.
Right. Now let's see if we can figure out the force that it will be able to lift. We know we're seeing 6, right? But let's see why. We know that P is equal to F over A. So if I cross multiply, I'll get F is equal to pressure by area. Right? Yeah, your math skills had to be able to do that. You had to be able to make F the subject, right? To make F the subject, you multiply P by E, pressure by area. So now I'm going to multiply the old pressure, which is 3 on 2, by the new area here, which is 4. How much you will get? 24, 2 by 3 is 6. So you see why the force is 6? Yeah? See why the force is 6? So I have a hard question for you, Michael. That's Michael, like the first thing you do, right? First time? Right? Here's the question after you, Michael. Michael, I want to get a bigger force here. I don't want it to be 6, I want it to be more than 6. What to do on the left side here? Huh? Decrease what? What part? F for the
F1.
huh?
F1.
Decrease the F, sure. Okay. Reason? Why should decrease the area or maybe force bigger? So let's see. Let's see if we can double it. Oh, by the way, right, that's not part of it, right? That's not it. Then let's see if we can double it. So it's now 2. Let's see if we can make the right hand side 12. Sure. Sit. Can I make it smaller? Where's the keyboard? I can't make it smaller. But here, what you can do for me, is use numbers. Right? Not use numbers, right? So you say we can make the area smaller. Let's change the area to 1. What would the pressure be? The U pressure will be 3, right? 3 over 1. And when you carry that 3 here, you will get 3 by 4, which is 1. Okay? So it means that same 3 Newton force can now lift 12 Newton. Yeah. Where you get lost, Michael? Yeah, when you lost space. No, all we did is we made the area smaller. So the area is not 2 anymore. We made the area 1. That's all we did. 3 over 1 is 3. That pressure will come here. And pressure by area here was 4. Pressure is 3 by 4 is 12. So now the force that we did there is 12. Twice as big. Okay? By making the area small. Alright, let's look at another type, right? Let's do my favor. Head up hydraulic lift and draw this example. Ignore D, right? Lean on your still. Draw the hydraulic lift. You can try putting man on with something else. Right, if you get in my paper, just right back in the pressure on the left side and power from the force at the right. Right back in that. And I want to give you a calculation. right? So I'm gonna give you some numbers. Same system. I'm gonna give you some numbers, right? Ignore what is seeing here. I just use the diagram, right? I want you to anyway change that. I want to work out this. So I want you to find F2, right? Find F2. Find F2. I given you F1. F1 is 10 newtons. F1 is 10 newtons. That's 10 right here. And A1 is, let's use 5. No, that's 2 ways, 0.5. 0.5 meters squared. Right? So that's F1 and A1, 0.5 and 10 newtons for F1. And I've given you A2. A2 is a lot bigger. A2 is about 10 meters squared. I want you to do your small calculations and tell me what is F2. Okay? Work out F2. Show up. All you have to do is in the Zoom chat, just message the answer.
Okay.
Right? Take your time. Do exactly what we just did, and I want you to see if you can figure out F2. So I wrote my hand right there. I did the mouse. Wait there. Right, we'll call it F2 bar, right? Much larger, right? How did you get you? Once you get it. Any answers next year?
Not yet.
That'd be a good question. I've seen. Yeah. The question. So what the answer? Right, so that's waiting on you, right? Yeah.
Okay.
Right, very good. Correct. So the pressure on the left side, is 10 divided by 0.5. Next time I use my iPad, we will this. Can I write a better now? 10 over 0.5, that's 20. Don't forget to write the SI unit with the Pascal. Right? And then to find force, we know that force is what again, Michael? Force is? No, come with the formula. Force is? You didn't write it down. I didn't write it down. So you don't think it was important to write it down? No, you're right. It's important to write it down. Right. Write it down, right? Force is equal to pressure by area. Right? And the pressure is the same. Pressure the same, depth is equal. So these 2 points have the same pressure. So the pressure is 20, area is 10. So the answer is 212. Always in physics, always write the SI unit, right? So the SI unit is newtons. Okay? Go on. Alright, let's go again. Copy down Michael, but let's go again. Okay, that's wrong, right? What time is it? Let's try the next one, right? Similar scenario. This time I am giving you F1. F1 is the same 10 Newton. But I'm not giving you E1. But here's what I'm going to tell you. F1 will be able to lift F2. F2, which is 500 Newtons. So 10 Newtons can lift 500 Newtons. And the area for A2, let's leave it at about what? I don't want to leave it at 50. Enough it. 50. I want you to work out A1. Take your time. Might have to kind of work in reverse. One brain. Yeah, I get everything on the spot.
Yeah, they passed by.
Hey, sorry, yeah, but I'm going to, I don't know, but yeah.
Yeah.
Kaboom. What again? Get method answer, right? Okay.
Yes.
Remember, it's the area, it can't be so big. All right, good job. What's the answer now? What's your name for Michael? Think about it. Like, think about it again. So on the left side, right? Ashish, on the left side, could you find the area? Could you find pressure? There you are, here. But on the right side, can you find pressure? By just dividing, right? So pressure is how much? Pressure here? No, 500 over 50 is how much? 500 divided by 50, this will cancel, and you'll get 10, right? Right? The pressure is 10 Pascal. Nice. So what's the pressure on this side? Same thing, right? I just find the area now. Pascal. I just find the area. Right. So area would be force divided by pressure. So it's 10 divided by 10, which is 1 meter. Okay. So you gotta be careful. Okay, so that's a practical example. I'll give you a practical. I want to okay, well, I want to show you a next example where we use pressure, right? That's what simulation that was. That was the simple model. Shia, you okay with this?
Yeah.
Or remote means people standing outside area of control. And always been done. Or to accept all requests here in the board. Give mouse and keyboard control. I'll try to clear them. All right, nice. Let me come out of this. Let me play up this here. And let's go back. Let's check. Let's look for the so what you will see is sometimes they have devices that can measure pressure. What? Yeah. Said manometer. Right? So that's the beauty of the this is the beauty of the physics, huh? That many things, if not all of the things that you use, have some physics in it. Right? Look like this tube. Where's physics? I might show you. But some people don't. Check out change. All right. So what you see, and I'm not sure if you've seen it, but right? Well, what you have here, right? What you have here, that picture, that's for sure, you see as well. You have a liquid called mercury in here. This liquid here is mercury, right? And the mercury is open to the atmosphere on one side, and then connected to gas on the next side. That's okay. So what you will notice right here is that the levels are equal. So what does that mean? If the levels equal on both sides, same pressure, very good. Pressure here is the same pressure here. Not bad at all, right? So, Ashish, what do you think will happen What do you think would happen if I make the pressure here larger? My next side, right? So the pressure will go down here, will push it down here, causing the liquid to go up here. Okay? That makes sense? Let me see. See that? And you see that there's a change in depth. But here's what the exciting thing is. What that allows us to do, that change in depth, this change in depth here, it allows us to find the pressure exerted by the gas. It allows us to find the pressure exerted by the gas. And watch out, right? Tell me if this makes any sense. We said that if this and this are the same level, the pressure equal. We said that? We said that at the same level, the pressure is the same. Right? So here what it's saying that if I have pressure acting here, that's the pressure of the gas, then the pressure of the gas should be equal to this pressure plus the pressure of the atmosphere. That makes sense? If here equals to here, then these two things I should be able to add it and get this. Doesn't give it up. So how would I find the pressure of the gas? Right? Here's how the manometer works. Well, I know that the pressure of the atmosphere is 100. 100 kilo. Kilo means 1,000. So it's 1,000 pascals. That's the atmosphere. And I have to add it to the pressure of a liquid. How do we find pressure in a liquid? Right? Density by gravity by depth. Right? So all I have to do now is find the density of mercury, which is a known thing. Right? They'll give me the value. And gravity is always 10 at this level, really 9.8. And the depth, 1.6. 1.6. That's it. When you multiply this and add it to 100,000, that's the pressure of the gas. That makes sense? Yeah? Sure? That make any sense?
Yes.
Yeah? Nice. Now let's not get any pressure in the book here. Here. Yeah, but that's just how it works, right? So what I want you to do from her is just head up, YouTube manometer, draw this small diagram and tell them. But I'll give you everything turn. Pressure on the gas, join this line into it. Pressure on the gas is equal pressure in the atmosphere plus pressure of the little column here. That's this here. I'll highlight it for you. That's the pressure of the column, but it's C. Okay? So let's make a note of that. That's the way the YouTube manometer works. That's one of the hardest thing in mechanics to understand. It'll come all the time. Come once in a while.
Video.
Huh?
You feel pressure.
Look at it. All right, look at it. I can want me to get ready now, have a five inches, 900, no. Yours is not chicken, but yours is. To stop watching things now. Yours was $600. Hey, by tomorrow you get out. That's super. I can't something previous to the board. Yeah. It's the code. Oh. Next. Finish? Alright, let me just give you one small calculation on this, right? Let's get it density on mercury. Write this down, right? At the density of mercury. Right, they have the density of mercury as approximately 13.5. Oh wait, no, hold on. That is grams per cm. No way, or kilogram. Use 5400. 5400, 5400. Yes, 5400. Huh? Mercury, yeah. Right, the density of mercury is 5400 kilograms per meter cube. Yeah, that's BC. Right, you can use that one, right? Right. Right, it's 5400. How about kilograms per meter cube? kg m to the minus 3. Right? So use the density of mercury as 5400, right? 5400. Right, I'm going to apply a force here. Let's apply a force here of about 13 newtons. Find the pressure on the gas. Find the pressure exerted by the gas. Right, so I want the pressure exerted by the gas. Pressure of the atmosphere is 100,000. This is 1.3, right? I want the pressure of the gas. 1.3 meters. Mercury, density of mercury, that is symbol for it. That's 54. Try to work for pressure of the gas. Take your time, right? You can write the exact value. Right, sure, you can just message the exact value, right? So the pressure of the atmosphere is 100,000. And we added, what's the formula for the pressure of the liquid again, Michael?
Pressure.
Yeah, what's the formula?
Density.
Right. So it will be 5400. Right, remember I told you gravity is always 10, right? So it's 5400 by 10 by what? 1.3 by 1.3. Right? Put it all together and much you got. One, 7, 2. 170, let me finish and does after that one. 200. Everybody else get up? Pascals. Sure. You got up?
Yes.
Yeah. So that's the way
Yes.
you yeah, very good. So that's the way you use a YouTube manual. Yep. Ashish, you hear that? Right. If there is someone that come back, let's come to grow. Let's come to wait and come back. And pass away the next week. Let's come to something. Yeah. All right, nice. So good. That's it for the first part of hydrostatics. We still have more. We have a story about a guy who ran outside naked for the week. Right? His name was a kidney. And he came up with a kidney principle. We'll do that when we come to that topic, right? So the next week we continue. We're gonna try and do a small experiment using ice or water, no, we use water.